So that is how dangerous the thing is. You can see all the way from up here, and then the etiologies will cause erosion. Then you are going to have a wound that is as deep as moving from the top here all the way to the muscularis. Very, very, very deep. All right. So now, in terms of the GIT, where do we know saying that normally you have it within the stomach, where you refer to it as gastric ulcer, or within the duodenum, where you refer to it as duodenal ulcer. So let's look at these two areas of the GIT. That is the stomach and especially the proximal duodenum. This is where normally the problem is. So looking at the structure of the stomach, so the upper curvature here, the first aspect that is very close to the esophagus, is referred to as the fundus. The fundus. So normally the LOS can be found here. That is the lower esophageal sphincter. That is very, very important when it comes to the problem with gastroesophageal reflux disease. But today, that is not the topic. So next time when we meet and we are talking about GERD, we may mention LOS and then try to explain its input when it comes to GERD. But today, it is ulcer. So the upper part here is what we call the fundus. From the fundus, then you get to the main body, which is also called the corpus. Then, getting closer to the duodenum, we have what we call the antrum. So this area is the antrum, and the part that is very close to the duodenum is called the pylorus. Obviously, there is a valve in between the duodenum and the stomach, just as you have a sphincter in between the esophagus and the stomach. Over here, we say that to regulate the passage of materials into the stomach and outside the stomach back into the duodenum, in which case you may get GERD. If you come to the junction between the stomach and the duodenum too, the pyloric sphincter regulates what is termed GIT emptying, so stomach emptying or gastric emptying, which means the passage of materials from the stomach into the duodenum is regulated by the pyloric sphincter. When it opens, then materials can move from the stomach into the duodenum. When it closes, then materials can't move. Again, if it opens, then you can also get backflow of duodenal content. For example, bile acid into the stomach, which can also come and then add on to the problem of GERD. So these are the four main areas of the stomach. The fundus, that is the upper curvature, the main body, also called the corpus. Then you have the antrum, and then the area that is very close to the duodenum is called the pylorus. Then the first aspect of the small intestine begins, which is duodenum. So in peptic ulcer, we are more concerned about the stomach and the duodenum. So you can see two areas, one within the duodenum and another one within the stomach, are colored red. Normally, these are the areas where most commonly persons who suffer PUD, their sores will be found. So around the lesser curvature here of the stomach and the proximal aspect of the duodenum. These are the areas that you normally see that the sores are, but it can be found at any part of the stomach, but commonly, and the duodenum as well, but commonly, the lesser curvature here around this area and the proximal duodenum. This is where the ulcers could be found. Any questions so far? Any question? All right. Then let's look at the various secretory cells found in the GIT that has any connection to the topic of the day, peptic ulcer disease. So these cells, what are they? Where can we find them in the GIT? And what do they secrete that can affect PUD? So the first one, parietal cells. Parietal cells. Parietal cells can be found within the fundus. You remember the fundus, the upper curvature here. You have parietal cells there. Then the body, that is the corpus. So the body, the main body, the one right after the fundus. So all this place all the way to the junction of the antrum. You have parietal cells also there. In connection to PUD, what do parietal cells secrete that we should be concerned with when it comes to PUD? Hydrochloric acid. So in terms of PUD, parietal cells that are found within either the fundus or the body of the stomach will secrete hydrochloric acid. Very soon we are going to look at the input of HCl when it comes to peptic ulcer. Then you find chief cells. Chief cells. Chief cells are also located within same areas where you have parietal cells. That is the body of the stomach and the fundus. Chief cells will secrete pepsinogen. Pepsinogen. One of the functions of hydrochloric acid is to provide optimum pH for enzymatic action and also to activate proenzymes. Pepsinogen is a proenzyme. This is not active. Before it can be active, it demands that hydrochloric acid should be around so that it will convert this inactive form to the active form called pepsin. So in the presence of hydrochloric acid, the inactive pepsinogen is converted to pepsin. And what is the role of pepsin when it comes to digestion? Anybody? What does pepsin do in terms of digestion? Hello?
I think it breaks down protein and amino acids into amino acids.
Yeah, so it is the enzyme that makes sure that proteins will be digested to the smaller unit for absorption. All right. So hydrochloric acid, as you know, is not always a bad guy. It's not always a bad guy causing injury to the mucosa or the lining of the stomach. Here, it is doing one good job, activating pepsinogen to become pepsin that will help in protein digestion. Apart from that, hydrochloric acid also gives the optimum pH for the various enzymes that are involved in digestion and other processes to be able to act. Then to the G cells. The G cells. G cells are also found within the pyloric antrum. So the pylorus and the antrum. So there is the antrum. Here will be the pylorus. So G cells are found there. G cells can also be found within the duodenum and even the pancreas. So the pancreatic G cells. What do they secrete? Gastrin. Gastrin, very soon we will talk about gastrin as one of those aggressive factors when it comes to the development of ulcer. Even more dangerous than hydrochloric acid. Then you have delta cells, which can be found within the stomach, every aspect. If any hormone or any enzyme or any secretory product is overshooting, normally it is somatostatin that will come in to stop that action. For example, the beta cells are over-secreting insulin, for example. That will put the patient too high. It can stop the over-secretion of the insulin. It's not only insulin, several other hormones. It is somatostatin that can prevent excessive secretion, apart from maybe the enzyme itself causing negative inhibition. Somatostatin is the main hormone that makes sure that excessive secretions are regulated. Then the superficial epithelial cells, this lines the entire GIT. So from the esophagus all the way to the last aspect of the GIT, you have superficial epithelial cells. And these cells are responsible for the secretion of mucus that lines the GIT and protect it from harmful agents. Then again, the secretion of bicarbonate that is capable of neutralizing the harmful effects of HCl. So in connection to PUD, these are the main cells and their secretory products that are of importance. So we are now going to discuss what they do, either to cause the problem or to protect us from getting the problem. Any question? Any question? Any question? Okay, so I hope it is clear. So now, gastric acid secretion. This involves both central, by this central, I mean the central nervous system, principally the brain and the spinal cord, and peripheral input, mostly the autonomic nervous system. So these two systems controls gastric acid secretion. How? These systems controls impulses or messages through, for example, neuronal receptors. For example, acetylcholine receptors, M3, that can be found on the parietal cells. Histamine subtype H2 receptors, also located on the parietal cells. And the cholecystokinin 2 receptor that is found on the parietal cells and the enterochromaffin-like cells. So you have these receptors there. It means that there will be agonists that will come in to stimulate them. And these agonists, for example, will lead to acid secretion. So with the M3, the agonist is acetylcholine. Obviously, histamine receptor will have histamine as the agonist, whilst the agonist for cholecystokinin 2, that can be located on the parietal cells as well as the enterochromaffin-like cells will be stimulated by gastrin. And normally, if you are moving from the lumen deep into the GIT, that is where at the back of the lumen, you are moving from the lumen to the GIT. Inside, we call it the basolateral membrane. That is where mostly these parietal cells are located, and you can find all these receptors on it. And if any of these agonists are around, then they can attach themselves to their receptors and possibly cause problems. If so, then how do these agonists and other inputs